calculate the difficulty and discrimination indices for multiple choice items. So in my spreadsheet, I have the scores for 16 students who did a 20-item multiple choice test. So here in column A, I have the names of my 16 students and the items here from 1 to 20. Now, 1 here indicates that the student got the item correct, whereas 0 signifies that the student did not get the item correct. So the first thing I want to do, I want to have the total for each student, the total number of correct responses for each student. So here I'm going to put total. So I'm going to sum the first student's score, which is Anna. So here we want to see. And we can see from here that Anna has 2 zeros, which means that she got 2 items incorrect. So therefore, her total should be 18. But we want to calculate this for all the students. So we're going to equal sum, S-U-M. We open bracket, and I'm going to highlight all of Anna's scores. So from item 1 to item 20, I close bracket and I enter. So that gave me 18. So now the other way we can do it, we can put equal sum and we can put in the cell address, which is from B. Anna's first score is in cell B7, right down to this one, which is U7. So it's the same thing. It's just highlighting them across is easier, in my opinion. So now we have the formula and we need to apply this for each student. So one easy way to do it is to copy down the formula. So here I would hover my cursor until I get the plus sign here, and then I would just drag this down and it will populate for me. So we have each student's total score. So we can see that Ophelia's total score is 11. We have Vita's total score being 10, and so on. So I want to order these scores from the highest to the lowest. But I want to ensure that I take the correct student with me, because if I just order them here, then it will assign based on the order in which the students appear here. So I want to ensure I take the right score with the right student. So I will highlight the scores and then I would drag this across to ensure I have everyone included. And then I would go to sort and filter, and then I'm going to select from largest to smallest. So now it has ordered them from the largest score or the highest score to the lowest score. Yes, previously we had the 9 somewhere up there. So now I have my scores in order. Now I want to have my items along column A and my students across, because I find it easier to calculate and put things to the right side. It's easier to follow than to put it at the bottom. So what I'm going to do, I want to get my students here to be going across horizontally here at the top. So I'm going to highlight everything, right? And I'm going to copy this. So I right click, copy, and I will I'm going to put it in the next sheet. Well, sheet 3 here. So I'm going to then right click and I would transpose. I'll select the paste with transpose. So here it gives me my students here at the top as I wanted. Let me just use a different color. Right, so I have my students at the top and the totals that I calculated earlier, they're at the bottom. So we have Anna, recall that Anna had gotten 18 and Vita had gotten 10. So their scores are down here at the bottom. Let me just highlight them to ensure that I don't drag them in any calculation when I'm doing. So I just put that in another color just to ensure I keep it separate. Right. Okay. So now we want to go ahead and calculate our difficulty level. Now recall that the difficulty level refers to the proportion of students who got a particular item correct. Sometimes we also see the percentage of students. So the difficulty level can range from 0 up to 1. 0 meaning no one got the item correct, as high up as 1, which means that everyone got that particular item correct. And in between, you will have from 0.1 going all the way up. So the closer the difficulty index is to 0, it means the more difficult the item is. The closer it is to 1, the easier the item is. So an item with a difficulty level of 0.7 would be easier than an item with a difficulty level of 0.3. Okay, so here I need to first calculate the total for each item, the total number of students who got each item correct. So here I'm going to put total. So I want to calculate the total for item 1. How many students got item 1 correct? Just looking at here, I could see that there are 2 zeros. So that means 14 of the 16 students got item 1 correct. So here we are concentrating on item 1. 2 zeros here, which means that there were 2 incorrect answers for that particular item. So I'm calculating here now. I want to determine the number of students who got each of these items correct. So let's go. So equal sum, open bracket, and then I'm going to highlight all of the students for item 1. And then I close bracket and I enter. So 14 students got item 1 correct. Let me just center it so I could see it properly. And then again, we can copy down this formula. We don't have to do it over for each student. So, or for each item. So I'm going to copy down the formula to my last item. So here we have the total number of students who got each item correct. So for item 14, 8 students got that item correct. Item 5, 11 students. Item 20, 4 students got that item correct. So we can already tell that item 20 was a difficult item. Okay, so then we can proceed now to calculate the proportion of students who got the item correct. So that's our difficulty, the difficulty index. So we're going to do that for here. So remember the first item, 14 of the 16 students got that item correct. So it is just as I'm saying it, 14 over 16. So we are just simply dividing 14 by the total number of students, which is 16. So here I'm going to equal and open bracket. So I'm going to highlight my 14 and then divide. And since 16 is going to be common to all the groups, we could all of the items because it's 16 students, I can type in my 16, close bracket and enter. So 0.875. Now I just want to have it to 2 decimal places and I just want to center it to have it looking a little better. So good. So here we have 0.88 as the difficulty index. This means that 88% of the student got item 1 correct. And then we must calculate that for each of the 20 items. So again, we have the formula in here. So that is why you highlight here rather than type it in so that you'll have the formula activated. So I will just go ahead and copy this down and I will have my difficulty for each item. Okay. Now we had some guidelines to interpret which the status of the items. So I'm going to use those ranges so we can determine our, so let me just bring the difficulty and the discrimination ranges and I will paste them at the bottom here. Good. So, right, so for difficulty, these are our ranges. We said the difficulty can range from 0 to 1. So from 0 to 0.24, it means that the item is difficult. If 24, only up to 24% of the students can get an item correct, we say that item is difficult. If between 25% of and 75%, so 0.25 up to 0.75, we say that item is of average difficulty. And if more than 76% and higher can get that item correct, we say it's an easy item. So we're going to use those to determine how we classify these items now based on the performance. So let me just, let me use interpretation. So we're going to interpret. Now we can look through this and we can determine from here which ones are easy based on the range there. But we can also have Excel help us to do this. So we can use the if statement. So I'm going to, so for the first item, equal if, so we go to our difficulty. Just bring this across some more. If the difficulty level, because that's what we're calculating. If open bracket, the difficulty level here is greater than or equal to, or greater than or equal sign 0.76, comma, then we open quotation mark, we say this item is very easy. We close quotation mark, comma, if we open bracket, the difficulty level, we go back to this, is greater than or equal to, the next one is 0.25, comma, we open quotation mark, we say the item is average, E-R-A-G-E, and we close quotation mark. Now, if it doesn't satisfy those two conditions, the other one is that it is very difficult. So open, we don't have to put the if for the last one, because if it doesn't satisfy these two, it will go in the next category. So very difficult. So those are conditions. Okay. Now we have two if statements here, so we would have opened two brackets. Therefore, we need to close two brackets here in the end. Let me just ensure that we have all. Yes, it seems that way. And we enter. So our first item is very easy. It's above 0.76. So as usual, we have our formula in, so we could just copy down to populate the rest. So here I'm seeing a very difficult one here. Let me put this in red. And here we have another very difficult one. Okay. Then we want to go on now to do our discrimination. So now you would recall that the discrimination is a measure of how well an item differentiates between the higher performing students and the lower performing students. So here we have a small population. We have 16 students. So we are going to use our 16 students. We're going to divide the group into two. So we'll have 8 in the upper group and 8 in the lower group. So you would recall when we had ordered the students' total score from highest to lowest. So we have them along the bottom here. So Anna score was the highest, followed by Bob, then Carla, and so on. So we have them ordered here. So now I can get my upper group. So I'm going to label them here now 1 to 8 to get the first group. So 1, 2, 3, and then let me see if I can highlight and drag this down 4, 5, 6, 7, 8. Okay, so that's my upper group. I'm going to put this in another color. What color have I used yet? Okay, right. And then the other remaining 8 students would be in the lower group. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are the lower group here up to this 8. I'm just using another color to ensure when I am copying I don't drag over. So purple. Okay. So upper group versus lower group. So here I need to, I'm going to put upper or top performers. Let me just put upper. So that would be my upper group would go there and my lower group would go here. So for this, I need to calculate the total number. I need to determine the total number of students in the upper group who got their items correct versus those in the lower group. So there was a total of 14 students here who got the item correct. How many of this 14 was in the upper group compared to the lower group? So we're going to add up the upper group. So as usual, we're going to start with equal sum. We open bracket, and I'm going to go here and highlight my upper group. So from 1 to 8. So that's why I number them at the top. And then I'm going to close bracket. Right? And I will enter. So there are 8 in the upper group. Well, let me see how many in the lower group one time. So equal sum, open bracket. So I'll go here by my lower group from 8 to 1, and then I close bracket. Right, so 8 and 6 is 14. So I'll just like to center my numbers. So then we just copy down. As a matter of fact, we could, yeah, what did I do? We can actually do both together. Right. So I have my upper and my lower, and we can just cross-reference. So we know that's 14, 3, and 5, 8. So, right, 8 and 2, 10. So we have our upper group and our lower group. Now, the next thing we want to do now is to get our discrimination. So the discrimination is a difference between those in the upper and the lower who got the item correct. So we're going to subtract those in the lower group from those in the upper group and divide by one group. So it's a total divided by 2. The total is 16. Each group had 8. So we are dividing by 8. So for the first item here, we're going to do a division. So equal, so I'll open bracket. And again, we're going to highlight rather than type in the number. So the upper group, so I highlight that, minus, we highlight the lower group. I close my bracket and I divide by the number in one of the groups, which is 8. So we have a discrimination of 0.25. And here again, I'm going to, now for anyone who would have missed it, I'll just do a second one and then I'm going to just pull down the other. So we're going to go equal, I open bracket, I highlight the upper group. This time the upper group is 3 minus the lower group, I highlight, I close my bracket, and then I divide by 8. So we have a negative discrimination for this one. Then I would copy down my formula for the rest. Okay. I just like to have things looking a little more orderly. Okay. So here we have some negative ones. We have this one is negative, which means that more persons in the lower group got this item correct than those in the upper group. So that happens anytime you have more in the lower group. You'll get a negative discrimination. This, where there's no discrimination here, because the same number of students in each group got the item correct. So it's not discriminating between any of them. Again, once you have more in the upper group, the discrimination is going to be positive, but depending on the difference. Here we have, there's a difference, a small difference, so it's 0.25. Here we have a larger difference. You have 8 in this group. Or let's use this one first. We have 6 in the upper group and 3 in the lower group. So you see it's a little higher than the one above, 0.38. And then this one, we have 8 in the upper group versus 2 in the lower group. So there's a discrimination, a high discrimination of 0.75. Now, similarly to the difficulty interpretation, we can also do this. We can look through, or we can choose to use Excel and have it do this for us. So let's put RE. So I'm going to just put the interpretations here. So we could use the if statement again to get it to determine. Now we have our criteria at the bottom here. So we're saying 0.19 and lower is poor. 0.2 to 0.29, we consider those marginal item. 0.3 to 0.39, reasonably good, and above 0.4 and above would be very good. So we're going to use those for the if statement. So equals if, and I open bracket, the discrimination, I need to take this further before it's gonna block me. If the discrimination is greater than or equal to 0.40, comma, we open quotation mark. What do we say about that item? It is very good. Close quotation mark, comma. If, open bracket, the discrimination, we go back here, is greater than or equal to 0.3, we are going to say, we're going to say that is reasonably good. We close the quotation mark, comma. If we open bracket again and we go back to our discrimination, we highlight that. If it is point greater than or equal to 0.2, comma, we are going to say that that is marginal, right? So we could close our quotation here. So the whatever is left would fall into the last category, which will be poor. So we're going to comma, and then we open quotation mark, poor. We close our quotation mark. Now, in this case, we had 3 if statements, so we would have opened 3 brackets. So therefore, we need to close 3 brackets. 1, 2, 3. Let me just double check that we have everything in. It seems that way. So we enter. So our first item is marginal. Okay, and then we copy down the formula for each. So I will just highlight the poor ones so we could just talk a little bit about those. Here, wow, there's a lot of poor ones. These two. Okay. We could ask Excel to color these two, but in the interest of time, I'll just go ahead and do it. Okay, so now we need to make some decisions regarding the items. What would we do with items that we get such stats on? So we could bring that over a little bit. So I'm going to put decision here and highlight a few. So in the why is it why are you going all the way up there? DECISION. So in determining, when making a decision about the item, we need to consider both the difficulty and the discrimination. We can't just base it on one. So definitely item. So we had one item here that was difficult. There's a difficulty index of 0.19. So just 19% of the students were able to get that item correct. However, it discriminated well because the ones that got it correct are the ones in the upper group only. So 3 persons got it correct, and there were 3 in the upper group. Now, what do we do with such an item? We don't want an item where the average student can't get it correct. So an item like this is too difficult, so we definitely can't reuse this one. So although the discrimination is reasonably good, we can't use this. Okay, so we may want to discard that one. The first item was considered to be very easy. 88% of the students got it correct. So we saw that 8 in the upper group versus 6 in the lower group, marginal discrimination. We can reuse this, so we could keep this because sometimes you need to begin your test with a easy item. So 88% getting it, and it's marginal, so that is one that we could keep. Definitely here we have average performance 0.5, but it's negative discrimination. So what we're seeing here is that of the 8 students who got this item correct, only 3 of them were from the upper group. So you had more students from the lower group getting this item correct. So most times an item like this tend to be ambiguous. Usually there's some misleading information because you expect generally that the students who score highest overall will do better on the items. So if a particular item, students who, let's say Anna got 18 overall, and if Anna didn't get this item correct, you might want to look into it. So you might want to inspect the item to see what about this, that Anna was doing so well, she got all the others correct almost all, and then this particular item stumped her. So there might be something about this item, but definitely once it discriminates negatively, there's no chance of keeping that item. So items like that you discard. If you look at the distractors and you realize that there's some distractors that were really not working, you can then replace those. So you can revise some of these items. You can revise them to make them a little bit more acceptable. But definitely you can't use them again in the current state. So we have this one. That's average difficulty. These two items, average, you had in both cases, you have this case, you have 2 more in the upper getting it correct versus 3 more here. And the discrimination vary as well depending on the number in the upper and lower group. So let me see if there's any that stand out. We have this particular item. This average difficulty, the discrimination is higher. So when we could definitely tell why that is so, because most of the students who got it right are from the upper group, just 1 in the lower group. So we know this was indeed a challenging item. So mostly the students in the upper group got it correct. So this is a good item if your focus is really on discriminating between those who know and those who don't know. This one, average difficulty, 0.5, but it's not serving any much purpose here. Those in the upper and lower, same number of students are able to get this item correct. It could be a case of guessing here, everybody just guessing it. But we want to see if we find a more robust item. So this would be an example of an item that would be considered to be more robust. So we have average difficulty, 63% getting it right. But of those, you see the 8 in the upper and only 2 in the lower. And this is discriminating very well. The discrimination is a lot higher than the difficulty level. So this is a very, very good item for discriminating. In this case, it seems as though the ones who got it right really know their stuff. The ones in the lower group were not able to score on the item. So this is the type of decision you want to make on your items. So you go through and determine which ones would have a chance of being revised, because from here you need to then look to see especially the ones with the negative discrimination or low discrimination. You want to see which distracted the students were chosen more. And then you'll be able to determine if those distractors were really rivaling the key, or it's a matter of the wrong key was highlighted, because sometimes that is the case. So the first thing you do when you have a negative discriminating item, you look to see if you had the correct key first. If the key, you consider the key is correct, then you go a little further to look at the question, look at the other distractors, and see if they could be double key, based on some misconception or the way information is shared. So I hope this is helpful.